Now let's look at some examples to see if they're functions and write some domains and ranges. So if you're given points or a table, in order to figure out if you have a function, the thing we need to check is the x values. If we have any x values that are repeated, that means we do not have a function. If none of the x values are repeated, then we're good to go. If we're looking at a graph, the way we're going to check it is to see if we pass the vertical line test. So in this first example, we have these points. We're going to look to the x values to see whether or not we have a function. So our x values, the first number in the coordinate point, those are -6, -5, -3, -1, and +6. None of those numbers were repeated, so this is a function. I would put ES for function. Then I'm going to write out the domain and range. The domain is the set of all x values. So I'm going to put D for domain, and then I'm going to use these curly brackets. Those mean set. So this set of numbers is our domain. And I'm going to put these numbers in order from least to greatest. So my smallest x value is -6, then we have -5, -3, -1, and 6. Those are all of the x values in this function. Then for the range, that's the set of all the y values. So we're going to do sort of the same thing, but we're going to put R for range. And we're going to look at the R values. Here, these are allowed to repeat. It's okay if we have multiples of the same thing. It's still a function. So our y values are -1, -9, -7, 7, and -9. So notice here we had two -9s. I'm just going to write that once. I don't need to write it 2 times. So -9, then we have -7, -1, and 7. Those are all of our y values in this function. Number 2, we have a table. This top row is all the x values, the bottom row is all the y values. So let's see if we have a function. Our x values are 2, -1, -2, another -1, and another -2. Because those numbers are being repeated, this is not a function. But it can still have a domain and range. This is just a relation, but there's still a domain, there's still a range. So all of our x values from least to greatest are -2, -1, and 2. All of our y values, the range, we've got -2, -1, 0, 1, and 2. So we've listed out every single x value and every single y value in this relation. Now let's move on to an example with a graph. Here we have this U-shaped graph, and to figure out if we have a function, we're going to try our vertical line test. So can we draw vertical lines through any section of this graph and only have that vertical line pass through the graph once? In this situation, we can, so this is a function. Now for our domain, anywhere that we have some sort of hole in our graph, for example, way down at the bottom of the graph, there's a little hole there. That means that it's jumping from the left side of the graph, makes a little jump, and then goes to the right side. So this point at 0, -1 is not part of our domain, but every single other point on this graph is. So to figure out the domain here, since it is continuous, meaning that every single point in between all of the other points is accounted for, we're going to use an interval. So going from left to right, since it's our domain, again, the domain is the x values, that's your left to right pattern. So from the left to the right, we have this arrow going to the left. That means that it's going to the left forever and ever, so we're starting at -infinity. Then from the left, we're going to go until we hit that hole. That hole is at the x value of 0, so I'm going to go to 0. And then because it's a hole and not a filled-in circle, we're going to use those parentheses. And then I'm going to put the union. Now, since this also starts at 0, I'm going to start the next part of my interval at 0. The reason being is because 0 is not part of this function, so I can't include it in my interval. That's why we have the parentheses instead of brackets. And then we're going to the right forever and ever, so we're going towards infinity. Then our range is the y values, so it's how low the graph gets to how high it gets. So the lowest that this graph gets is right here at -1. Again, there's a hole there, so I'm going to use parentheses. My lowest number is -1, and then we have arrows pointing upward forever and ever so we're going towards infinity. Last one. Does this pass the vertical line test? Yes, it does. So our domain. First thing to check, are there any holes anywhere in our graph? Does it jump from one section to another? No. So domain is left to right. The farthest to the left that this graph gets is negative infinity. So we're going to start there. And then it's going to the right forever and ever, so it's going towards positive infinity. The range is the lowest that the graph gets to the highest that it gets. So this arrow is pointing downward, that means we're starting at negative infinity. And then the other arrow is pointing upward, so we're going towards positive infinity. You may also see this interval written as all real numbers, this R with an extra bar in it. These two mean the same thing, so negative infinity to infinity or all real numbers. You can see both of those written and they mean the same thing.